Hi, we're looking at another example of frames here. And so here's the clamps that's holding woodworks. And the clamp has dimensions showing here. And they said the jaw has certain width, 43 millimeter wide in a direction perpendicular to the plane of picture. So that really means it's 43 millimeter. That's the depth of it, right? It's how deep going from the screen in. And the screws of clamp are adjusted so there's a uniform pressure of 185 kilopascal applied for the work piece by the jaws, and then want us to find the force carried in each screw, which is FAB and FCD here. So if they give us the pressure 185 kilopascal, that's our pressure, and we know pressure is force over area. And if we want to find the force, we just need pressure times area. Mine is 185 kilopascal, and the area, so the pressure is applied here, and it's perpendicular to those arrows, so with the depth is 43. Then we just need to know there's this dimension, which is h, and it's a rectangular cross section, so it's h times the depth, which is our 43 millimeter. Now we can put our values in. My h is 50 and depth is 43. Now we need to look at the dimension. It's kilopascal millimeter square because both h and depth is in millimeter. Then you can calculate that. Here I just want to demonstrate the unit because kilopascal, let's take a look at it here. I'm gonna start at a new spot. So Pascal we know is Newton per meter square, right? Force over area. And if we're going to change this, so kilopascal will just have kilonewton per meter square right here. Then we need times millimeter square. Then either we can change this millimeter square to meter square, right? So let's do that. We know 1 meter is 1,000 millimeter. Then however we look at square, so millimeter square, and don't forget there's 1,000 square as well. So millimeter square cancel out, meter canceled out. Then what do we have is this value you have there divided by 10 to the power of 6, because that's 1,000 square, right? And that's going to give us a unit of, this is some value you calculated. It's going to give us a unit of kilonewton. And likely, we're going to change to Newton. So we're going to times 1,000. So it's whatever this value you calculated divided by 10 to the power of 3 divided by 1,000. That's going to give us a unit of Newton after you times 1,000 there, right? So once we have this value, we know exactly how much force is applied right here by the workpiece. So how do we find the force applied by the screws? In order to do that, remember frame, you can look at the entire structure or you can look at individual. Here are the many individual pieces. You have this this particular vise, one on the left, on the right, and then you also have the screws. Then you also have those work pieces. And I decided to just looking at I hope you can see this highlight. And we just decided to look at this the left jaw, right? In order to do that, I'm going to draw the FBD of just that part. That's where the screws go through. So if we look at this FBD only, what forces do we have there? What's in contact with this left jaw? You have workpiece right here, right? This workpiece is going to apply the pressure, apply the force on here, and it's going to be, we'll assume it's going to be right in the center right here. So that's going to be that. And that's the force you calculated right here from this step. Then you also have the force applied by the screw here. Then we don't know the direction, but you thinking about it, if you are pushing this workpiece here, and this screw is gonna push it in, right? So you're gonna just have to thinking about this is push it in, and that's what we're calculating, FAB. And this screw CD is gonna push this side in the opposite direction, or I can go ahead and draw like that. Oops. That's going to be our FCD, right? We'll have those two forces there. And that's all the forces acting on this left jaw. And we can go ahead and solve it. Traditionally, we'll go ahead and do the force at X direction and force at Y, but the force at Y here doesn't really bear any fruit, right? Cannot give us anything because there's no forces at Y. So what we could do, we can do moment, right? We plan to do moment anyway. If we do moment about C, we can go ahead and find FAB. If we do moment at A, we can find forces at CD. So let's do moment at A first. So this is where we do moment about, this point. All right, then what do we have? We have this force right here. Then what's the moment of arm? Remember, this force is applied in the midpoint. So that's going to be half of the H, right? Plus this D. So we can go ahead and write down half H plus our D. That's moment of arm. And that rotation is clockwise, so it's positive. And now you're thinking about it. What's going to be the unit we're getting? This is in Newton. We did over here. And if this is in millimeter, right? We keep as millimeter because everything else is millimeter. All right. Now let's continue write our equation. We'll have our FAB does not show up in the equation because the FAB going through point A. Now we just have FCD. And the moment of arm will be just that distance. And that distance happened to be C. So we times C. And that rotation is going to be clockwise, so it's negative. Right? Then what do we have now is going to be that entire thing equals 0. Now let's look at the units one more time. This is FCD solving, and it's going to be a unit of Newton, and this is going to be in millimeter. So do you need to change this millimeter to meter? No, because you both have millimeter, okay? Then they equal to 0 here, so you can go ahead and cancel. You don't need to change that millimeter, all right? Then from this equation, you can go ahead and solve your FCD. Once you find the FCD, you can bring up to our forces at X direction equation because you can go ahead and find the FAB. FAB positive minus F, the force applied by the wood piece, the one you calculated, and minus FCD you just calculated. Then you can solve for FAB. All right, so that's for this problem. I'll see you next time. Bye.